In this lesson, we're going to explore internal energy, which we covered previously, discussing it as a state function. Internal energy, or delta U, equals Q, which stands for heat, plus W, which stands for work. We can think of this as the sum of the kinetic and potential energy of all the atoms, molecules, particles in our system. So we get kinetic energy from the motion of the particles and motion within those subatomic particles. So just because we can't see the motion doesn't mean it's not happening. We're only worried about the change in energy when we're looking at a system or surroundings, not anything about an absolute value of it. Just like with heat and work, we can talk about the sign conventions that we see for internal energy. So when we have internal energy and there's a net movement of energy from the system into the surroundings, so out of the system, we get a negative value. When we're talking about a positive energy for the internal energy, we see that energy is flowing into the system. Putting this all together, we see that we have negative values of work when it's done by the system, when it loses heat to the surroundings, and when there's a net flow of energy out of the system. And we can have a net flow of energy out of the system even if both values are not negative. We can have one positive and one negative, and then it depends on the magnitude of those values. For positive values, we see work done on the system, heat being gained from the surroundings by the system, or a net flow of energy into the system. Let's look at an example. A system gains 165 joules of heat and does 92 joules of work on the surroundings. What is delta U? Well, we know delta U equals Q plus W, or heat plus work. But we can't just plug those values into our equation. We first need to establish if these values should be positive or negative. We see that the system is gaining 165 joules of heat, and therefore it's going to be a positive value, and it's doing 92 joules of work on the surroundings. Therefore, that value will be negative. And we get 165 joules plus a negative 92 joules, and we get delta U equal to 73 joules. Note in this case, both of the numbers have the same units of joules. You may see problems where they don't, and in that case, you need to convert them both to the same number. It won't matter if you convert to joules or to kilojoules, but the units must be the same for both heat and work before you combine them in this equation. Now, we see that there's a net flow of energy into the system because we have a positive value for our internal energy. Even though the work is negative because it's being done on the surroundings, we can still have a positive internal energy. A system loses 75 joules of heat and does 45 joules of work on the surroundings. What is delta U? Again, we need to determine what the signs are for heat and work. The system is losing heat, so we'll have a negative value for heat, and it does 45 joules of work on the surroundings, which means that value will also be negative. Therefore, delta U equals Q plus W. We get minus 75 joules plus a minus 45 joules, and delta U equals minus 120 joules.